All right, so we've seen how L'Hopital's rule can help us find limits of ratios of functions where the indeterminate forms are 0 over 0 or plus or minus infinity over plus or minus infinity. And actually, of course, we have all kinds of different other functions, well, this is, what L'Hopital's rule would be used on. But if you can just have other indeterminate forms, like you can have infinity minus infinity, for instance. Okay, that's an indeterminate form. You can have 0 times infinity. That's an indeterminate form. But in order to figure out what if the limits exist for these kind of situations, we have to be able to rewrite our expression as these two indeterminate forms, 0 over 0 or infinity over infinity, in order to apply the L'Hopital's rule. And here in this problem, we have another situation where, okay, we have the limit as x approaches 0 from the right for the function 1 plus the sine of 4x raised to the cotangent of x power. Okay, so it turns out that, well, 1 plus the sine of 4x, since, what would 1 plus the sine of 4x approach as x approaches 0? Well, that's going to approach 1 plus the sine of 4 times 0, which is 1 plus the sine of 0, and that just equals 1. So the base approaches 1. On the other hand, the cotangent of x here, that's your power, that's going to approach the cosine of 0 divided by the sine of 0, because cotangent is cosine divided by sine. Well, and if we're doing it from the right, that's just going to be, that's going to be like 1 over 0. And that's 1 over 0, that's infinity. So in this case, your indeterminate form is 1 to the infinity power. That's another indeterminate form. So just like with the previous problems, we have to manipulate this limit so that we're able to utilize L'Hopital's rule. And that means I have to get some function f divided by some function g. But this problem is harder because you have that exponent, which is the cotangent of x. So we're going to have to do a little trick on this in order to determine the limit. We're actually going to have to utilize the log function to help us. So let me show you how this would work. Okay, are there any questions so far, though? Okay. All right, so again, this in our solution, this is the limit that we want to find. And what I'm going to do is I'm going to let y equal 1 plus the sine of 4x raised to the cotangent of x power. Okay, in other words, this here equals y. Now what we're going to do is we're actually going to look at the natural log of y. The reason we want to do this is because we need some expression we can find the limit of. And remember from your log rules that if you have the natural log of a to the bth power, that equals what? What is the log of a to the bth power? Do you remember from your log rules? That's right, Opiemi. Very good. That's right, Javier. That's b times the natural log of a. So you see, if we, rather than looking at the limit of the function y as x goes to 0 from the right, let's look at the limit of the function the log of y, natural log of y, as x goes to 0 from the right. Well, that would be the same as the limit of the cotangent of x times the natural log of 1 plus the sine of 4 of x as x approaches 0 from the right. But again, I need a function f divided by a function g. Okay. Well, it turns out we actually can get that quite easily because the cotangent of x is defined as 1 over the tangent of x. And so this limit can be written as the limit of the log of 1 plus the sine of 4x hold on. It's not, let me see here. It's not, okay, let me do it this way. Right, so the log of 1 plus the sine of 4x divided by the tangent of x. So now you have your function f over your function g. Now, is this an indeterminate form that we can use L'Hopital's rule on? The answer is yes, it is, because, hold on here, everybody. Why this isn't, all right, I have to do it with the mouse. The numerator approaches the log of 1 because the sine of 4x as x approaches 0, that's going to go to 0. So the numerator will approach the natural log of 1, which is 0. The denominator, okay, will approach the tangent of 0. And that's just 0. So we have the indeterminate form. We have the indeterminate form 0 over 0. And so we can apply L'Hopital's rule. So the derivative of the numerator, we need to use the chain rule with three functions: the natural log, 1 plus the sine of 4x, and then 4x, you know, outer to inner function. And so here's the chain rule derivative of the numerator. For the denominator, the derivative of tangent is secant squared. Now this actually, we can compute the limit on. Okay, this if we, so I get here, but let me put in an extra step here. Let me put in a little bit of an extra step. So we're going to have 1 over the sine of 4 times 0 times the cosine of 4 times 0 times 4, all divided by secant squared of 0. Okay, so, well, the cosine of 4 times 0 is just the cosine of 0, that's 1. The sine of 4 times 0 is just 1. No, that's 0, sorry. So you see, I'm going to get 1 over 1 plus 0 here, times 1 times 4, all in the numerator. Now for the denominator, the secant squared of 0, well, secant squared of 0 is equal to 1 over cosine squared of 0. And that's just 1 over the cosine of 0 squared, which is going to get me 1 over 1 squared. And that's going to be 1. Well, 1 squared. So see? So I end up getting 4 as my limit. That's the limit of the natural log of y as x approaches 0. The limit as x approaches 0 from the right of the natural log of y is equal to 4. But what we're interested in is the limit as x approaches 0 of y, of the variable y, the function y, I should say. That's what we're interested in, because, well, from above, you know, in the notes, this is what we're interested in up here, in finding. So if I know, well, first of all, are there any questions?
For our final answer, would we not use the original limit?
We are going to have to use that, Mohammed. We are going to have to use the original limit. We are. And right now, all I know is this limit here. Let me go to the whiteboard for a minute. Let me ask you a question, everybody a question here. So does everybody have this down? We have one more page, but let me go to the whiteboard. Okay, so let's. Okay, so if you know the limit as x approaches 0 from the right of the log of y is equal to 4. Okay. How would we find the limit as x approaches 0 from the right of y? What would we have to do? What do you think? How is y related to the natural log of y? How are they related? I want to write y, but I want to write y to include the natural log of y. In other words, y is equal to what raised to the natural log of y power? What's going to go here? Well, hold that thought, Javier. Hold that thought. This is sort of a separate thing from the 4. I just want to write y as something raised to the log of y power. A number. I'm looking for a special number. That's right, Mohammed. That's right. That is going to be e. Y, let me just kind of hold on here. Getting better with this eraser. Y equals e to the natural log of y, right? Because an exponential function, how many remember exponential functions and logarithmic functions are inverse functions? So wouldn't this just be equal to y? I mean, is anybody uncomfortable with that? Javier, how are you with that? Are you okay with that? Good, good. Well, so look what I can do here. I can write y as e to the natural. That's right. That's right, Mohammed. They're canceling each other out because they're inverse functions. So I can write y as e to the log of y. E raised to the power log of y. So what would that equal then? What would the limit be? Since the log of y approaches 4 as x goes to 0 from the right, what would e to the log of y approach as x approaches 0 from the right? What answer are we going to have here? That's right. Good, Mohammed. It would be e to the 4th power. And so that's going to be our limit. Now I can formalize that. Let me go back to the solution here. I have this in the solution. I mean, I have, let me just go back in here. So in our solution, remember, y is equal to 1 plus the sine of 4x raised to the cotangent of x power. And we're interested in the limit of y as x approaches 0 from the right. We discovered that the limit as x approaches 0 from the right of the log of y was equal to 4. Right? That's what we discovered. And so what we can do now is we can say, okay, well, you know, here's the limit I'm looking for right here. But I had defined 1 plus the sine of 4x raised to the cotangent of x power. I define that as y. So I'm really looking for the limit as x of y as x approaches 0 from the right, but y is equal to e to the log of y, e raised to the log y power. So that just gets me e to the 4th. And so amazingly, this is really amazing, the limit, let me just put it in blue here. Hold on. The limit as x approaches 0 from the right of 1 plus the sine of 4x raised to the cotangent of x power. It's an ugly expression, but I've seen them. I've had to find limits of these kind of expressions in my own math career. That's going to equal e to the 4th power. And that's what WebAssign would want, by the way, too. It's not going to take a decimal answer. How many think that's kind of fascinating, what you just learned there? Maybe if I had a few thumbs up, that'd be nice. Even, okay, Mohammed is good. And Clea is good. Thank you, Clea. Thank you, Mohammed. And, you know, that's section 4.5. Thank you, OP Amy. Appreciate it. Are there any questions? Okay, well, I'll stop the recording here.